A little bit about the factorial symbol. It's a blast off symbol, right? It starts at a number, you go down by 1 the whole way till you get to 1 and blast off, correct? Factorial symbols can also work if you just get down to the number 2. Like say I did 5 factorial. That is actually represented by 5 times 4 times 3 times 2 times 1. But multiplied by 1 doesn't do anything, right? So that is actually the definition of factorial. 5 factorial is working your way down to 1. But you could use the 5 factorial symbol if you had 5 times 4 times 3 times 2 as well, because the 1 doesn't affect it, right? Just noting to self. But the definition would be it actually has a 1 on it. Okay? So if I did it with n factorial instead of a number, I would start at n, and then I would multiply by 1 less, then I'd multiply by 1 less than that, so n minus 2, then 1 less than that, n minus 3, and I'd keep going. Because until you know what n is, you'd actually have to keep going for forever, because you have to go until it's 1. Well, if n was 3, let's say, if n was 3, then I would get 3 times 2 times 1, and I would stop at n minus 2, because that would hit me to 1 already, right? But when it's n, you just keep going, because we don't actually have a limit at that point. So we use these because there's the formulas on your formula sheet for NPR and NCR at the very bottom left. This is all the formulas for this unit, permutations, combinations, binomial theorem. So it says that n factorial expands. It says that 0 factorial is 1. It gives you the NPR and the NCR formula. And these have factorials in them, right? So the reason why we learn about factorials with n's is because we're going to have to use these formulas to solve. Okay? You're going to get one of these formula sheets next week. I have to buy the plastic sleeves. All right. So we're going to start with expanding them. So example 1, simplify the following expression. Leave the answer in product form where appropriate. Product is just multiplication form, right? So you don't have to expand it. That's what it's saying. So how we expand these and how I think about them is if I gave you this, let's think about this in just numbers, not letters. So say I gave you 5 factorial over 3 factorial, and I expanded them out completely, okay? We would get 5 times 4 times 3 times 2 times 1, and the bottom we would get 3 times 2 times 1. And then technically, the little one can be completely canceled off from the big one, and I'd be left with 20. So I wouldn't have to do all the numbers. We agree? The little one would cancel off the big one, right? So when we have letters, variables, then we're going to do the same thing. We're going to expand out the big one, and we're going to expand out the little one, and the little one should cancel out the big one. It's a little bit harder to see which is the big one and the little one when it's variables. So what I always say is plug in like a 2, and then you'll know which one's bigger. So if I plugged a 2 in for n, this would be 4 factorial, this would be 2 factorial, correct? If I plugged a 2 in for n. So the top is actually bigger than the bottom, is it not? So the bottom we know is going to, the denominator is going to cancel away, and the top's going to stay with something. Does that make sense? So we're going to expand the top out till we get the bottom. Because the top is the bigger one. So we always expand the bigger one out till you get the bottom one, because the bottom one will cancel out, just like the 3 factorial did, right? I could have went like this instead of expanding the whole thing. I could have left the 3 factorial on the bottom, and I could have went 5 times 4 times 3 factorial technically and canceled the 3 factorials off. Could I have not? It's the same thing, is it not? So if you figure out which one's the bigger one, you expand the bigger one until it matches the little one and cancel it off. Okay? So if I plugged a 2 in, like I said, this would be 4 factorial over 2. So I know this is the bigger one. So I'm just going to rewrite the little one. And I'm going to expand the bigger one. Now, how do we expand it? Bless you. We go down by 1 each time. So we're going to have n plus 2. And then what's 1 less than n plus 2? N plus 1. And then 1 less than n plus 1? It's just n. Because if I take a 1 off of n plus 1, I'm just left with an n. Correct? And that's going to match, isn't it? Why do I put the factorial symbol behind it? Yeah. You know why?
I don't know if because 0 factorial is 1. So
yeah, so you're gonna end up keep going until you get to that 0 factorial, but we just don't know what it is. So this is going to keep going, so that's why we put the factorial symbol, because we don't know what n is. Yeah. So it's going to just keep going. So technically you're right, because you would go till you get to 0 factorial. We just don't know what 0 is.
Okay.
So this baby keeps expanding until they would actually tell us n is 7, and then we would know when to stop. But when n is n, we don't know when to stop. So the factorial keeps going, and then these actually completely cancel off, and I'm left with n plus 2 times n plus 1. Done. So we're just simplifying them out. So you always have to figure out which is the bigger one, expand it till it matches the smaller one, cancel off. Okay? So if I look at B, which is the bigger one? Well, let's plug in a 4. 4 minus 2 is 2 factorial on the top. 4 minus 1 is 3 factorial on the bottom. So which one's bigger, the top or the bottom? The bottom, technically. So that's what I'm going to expand. So I'm going to go equals, and I'm going to write the n minus 2 factorial again. And then I'm going to expand the bottom till it matches it. So how do I expand it? I just rewrite it. N minus 1. What's 1 less than n minus 1? N minus 2. And now they match, so I'm going to put the factorial symbol. Then they completely cancel off. We agree? Now, when we are actually canceling off, do you know what these lines are when you're canceling? They're just really slanted ones, are they not? Every time you cancel something off, you're left with a 1 behind it. It cancels off and a 1 is replaced. It cancels off and a 1 is replaced. So these are just really like largely slanted ones. So does the whole numerator just go away and vanish? No, what are we left with in the numerator? A 1. It's a really slanted one. So we're going to write it not slanted in the next step. C is that little bit different. C is n factorial over n minus 1 factorial. The only one we can expand is the one with the factorial symbol, correct? So that's the only thing we can do in this one. It doesn't matter which one's bigger or not. That's the only thing we can expand. So we're going to rewrite this because there's nothing I can do to it. It doesn't have a factorial symbol. And then I'm going to expand the top. So n factorial is n, and then 1 less than it is n minus 1. Now, some people will say, okay, they match. I'm going to put the factorial symbol. The factorial symbol without a number or anything in front of it is an exclamation mark, and you can use it in English. That's what it is. Okay? So if you have just this random, this sitting on a page without anything in front of it, that's an exclamation mark of which we don't care about because we're in math. Okay? If I put something in front of it, that's actually the number 6 because it's 3 times 2 times 1. Correct? Or if I have a factorial symbol, I have to have a letter sitting in front of it, or it's literally an exclamation mark and completely useless. Okay? So if I went and put a, don't do this, I'm going to erase it. If I put a factorial symbol here and cancel these all off, what am I left with on the top? Just an exclamation mark, correct? Is that helpful to us? No, that's English. It's like we're screaming, like, hello, and they put an exclamation mark. That's what that's for. In math, not helpful by itself. So I actually have to go one more. I can't stop at n minus 1. I have to actually go to n minus 2 factorial. So that when I cancel these off, that factorial symbol still has something sitting in front of it. If I had stopped at n minus 1 and put a factorial symbol, I wouldn't be wrong. But the moment I cross it off, I just have an exclamation point sitting there, which is useless. Okay? So the answer to this one is n minus 2 factorial. We're going to come back to this. I'm going to have you work on a couple questions. They're in your homework anyways. So go ahead. A page. Maybe 2 pages. 1 page. You're going to try. I was bored. So you're ahead a page. You're going to do these 3. Now the thing to note is if you want to know if you're right, you can go ahead one more. Nope. Just look at the bottom, actually. I lied. At the bottom are the answers. So you're trying these 3 out. I'll give you a few minutes. So we're back a page and we're on to this equation here. So this one says algebraically solve this. Now, just so you know, this is going into the permutation formula. This is like the permutation formula filled in without you even doing it. So what we're doing right now is I'm giving you the permutation formula filled in, and I just want to see if you know how to actually use it. Then in the next example, we're going to learn how to fill it actually into the formula. But we need to be able to deal with the formula first. So until this question, we just dealt with kind of like, hey, if I gave you factorial stuff, can you reduce it? Now this one, I'm saying, hey, if I give you factorial stuff and they set it equal to a number, can you solve for what n is? Okay? So it's not overwhelming. It's the same as what we just did. So we always rewrite the question. We don't work from underneath the question and then tell Mrs. Lepp I didn't give you enough space. Like some people, the question will be here and you guys will work down and then I get arrows and loops and stuff back and it's just chaos. Okay? You don't have to work from right below where the question exists on the paper, right? We can rewrite the question on the far left and we have so much space to mark. We're going to do that. So we're going to, I'm acknowledging that I have a pen in my hand. So n factorial over n minus 2 factorial equals 42. So I'm just rewriting it. That's all I'm doing. And I know how to solve stuff from grade 11 with quadratics and all that. I can do that. You'll remember it, whatever. I can do linear. I can do all that. What I don't know how to do is solve when there's a factorial symbol in it. But we just learned how we can get rid of factorial symbols, right? We take the largest one, we expand it till it matches the smallest one, it cancels it off with the factorial symbol, and then the factorial symbols are gone, and I'm back to grade 11 math. Okay? So, which is bigger, n factorial or n minus 2? N factorial, because if I plug in like a 6, this would be 6 factorial, this would be 4 factorial. We agree? So, I'm going to rewrite the smaller, and I'm going to expand the bigger one until it matches the smaller one so that the factorial symbols will cancel off. So if I start at n, 1 less than n is n minus 1. Still doesn't match the bottom, so I don't stop. 1 less than n minus 1 is n minus 2. Now that matches the bottom, we agree? I put the factorial symbol behind it, and they completely cancel off, and the factorial problem is gone. The factorial problem is bye-bye. Okay? Now you actually have a grade 11 question. This is 20-1. So I'm just going to rewrite it without the cross-off. So I have n minus 1 equals 42. What's the next thing I could try and do? Starts with a D. Rhymes with distribute. We could distribute. Yes, we could. Good job. So we distribute the n, and we get n squared minus 1n equals 42. Now in grade 11, we learned that if we have a squared, an x squared, an n squared, an m squared, it doesn't really matter. If we have a squared, we have to move everything to one side and set it equal to 0 every single time. We'll move it all to one side, set equal to 0. If it's linear, you can isolate the variable and giver. If it's a quadratic, which this one is, when there's a squared, you have to always move everything to one side, get it equal to 0. So I'm going to have to subtract the 42. So I get n squared minus n minus 42 equals 0. And then I factor. If you're someone who still can't factor, today's the day to tell yourself, I can't factor. And then come in and get help. Okay? So, it's what multiplies to get you the outside numbers, what multiplies to get you negative 42. And what adds to get you the middle. What plus what equals negative 1. So what two numbers multiply to get me negative 42 and add to get me negative 1? Negative 7 and positive 6. So we're going to get n minus 7 and n plus 6. And the reason why I can go right to brackets, if you remember from grade 11, is the moment it has a plus 1, it has to be a positive 1. If it's a minus 1, you either have to move everything to the other side, or you have to do decomp. So if it's a plus 1, you can go right to brackets. So all we did right now is grade 10. Grade 10 is factoring, right? Then grade 11, we had that extra step. where you took each of these and you set them equal to 0 now. So you go n minus 7 equals 0, n plus 6 equals 0, add the 7, n equals 7, subtract 6, n equals 6, or sorry, n equals negative 6. One of these will be extraneous. One of these will not work. And remember, factorial symbols don't work with negatives. So if I plug this back in, I get 7 factorial over 5 factorial, and if I type that into my calculator, it tells me it's 42. So this one's good. If I plug this one in, I get negative 6 factorial. I can't go anywhere lower than 0, technically. So negative 6 factorial can't happen. So we circle this one. You have to circle it, put a line through it, which means you've just said, okay, I can get that answer. It doesn't work, and it is extraneous. So the answer you would pick is 7, right? Okay, then we have the permutation formula. It's NPR equals n factorial over n minus r factorial, which looks a heck of a lot like this. N factorial over n minus r factorial, right? Same formula. So, if we go over one, this is why we're learning it. Because we get stuff like this. Determine the number of total objects you have to choose from when arranging. Arranging means permutation, which is what we're going to start doing tomorrow. It's telling me order matters, so it's a permutation. So I want the total objects, so I want n. N is how many there are. The total objects you have to choose from when arranging 3. So 3 is how many you're choosing. So that's your R. So when you're choosing 3 of those objects, and it results in 1,320 distinct arrangements. Should have an S. Algebraically. It results in this. What is this? This is just the what? That's what the answer is, right? That's the answer. It results in this many arrangements. So that's your answer. What it equals. So the NPR formula is this. NPR equals n factorial over n minus r factorial. It's on your formula sheet. And this is just a glimpse into what we're doing, because we're doing permutations right over here. Okay? This example I'm giving is to show you why we're learning this factorial stuff. It's not going to make the best sense to you right now how I got the numbers and stuff, and that's okay. I haven't taught you that yet. I'm just showing you how this example is going to come up and why we're learning this. So our n is n. We don't know how many numbers we're choosing from. So we're going to have n factorial over, and then n minus, what was our r? How many are we choosing to arrange? 3 factorial. Now the key thing about this formula as well is your n has to be bigger than your r. N is how many you can choose from. R is how many you're choosing. So I can have 10 objects and choose 10. I can have 11 objects and choose 10. I can't have like 8 objects and choose 72. Like that doesn't work. So your n has to be equal to your r, or your n has to be greater than your r at the very minimum. Or your calculator will not let you type it in. Okay? And what does this equal? What was the total? 1,320, right? So we're doing it the same as we just did the last example. Which one's bigger, n factorial or n minus 3? N minus, or the n, so let's put in a 7. This would be 7 factorial. This would be 7 minus 3 factorial. So this would be 4 factorial. So which one's bigger, the top or the bottom? The top. And for this formula, the top will always be bigger, just so you know. So n factorial, oh, that's one more expanding. would be n minus 1, n minus 2, n minus 3 factorial. And it equals 1,320. Do you see how I set it up? This one's specifically in here because you can't solve it yet, just so you know. So if we expand this, we're going to get, we have to expand, and then every time you hit an end bracket, it screams, stop! That's what it screams. Stop! No more. So we get n squared minus n in a bracket times n minus 2 equals 1,320. And then we FOIL this out, so we get n squared times n is n cubed. N squared times negative 2 is negative 2n squared. Negative n times n is negative n squared. Negative n times negative 2 is positive 2n. And it equals 1,320. And a cubed is like a squared. Everything has to move to one side, set it equal to 0. So we're going to get n cubed minus 3n squared, because you put them together, plus 2n minus 1,320 equals 0. And today, we're stopping there. Because can we actually solve a cubic yet? No, but very soon we will be able to in polynomials. So it shows how you can put the two together. Put this unit with polynomials. But we're stopping there because we can't solve a cube right now. But I just wanted to show you where we can go with this. Okay? We're not going there today. I want you to go here. And you're just doing these for homework. That's it, just number 2. A hint to this one is divide the n minus 1 over first. And don't worry about that one. So A, B, C. That's your homework. Enjoy it because it's small.